So you may or may not remember back from Math 1, you saw systems of equations, linear equations. So here's an example. You know, we have 2x plus y equals 4, and you have x plus y equals 6. And there's a couple different ways you solve it. One way is you could graph them. So you get them both in the y equals form. That would be negative 2x plus 4. This one would be y equals, what, negative x plus 6. You would graph them both and find their point of intersection. So when I say solve a system of equations, what I'm trying to do is take these two equations and I'm trying to find a common solution. In other words, what's an xy combination that will work with both of them? Well, when you did linear ones last year, you know, let's graph those real quick. This won't be super accurate, just a real fast one. But if it has y-intercept of 4 and I'm going down to over 1, you know, it's going to look something like this. And then negative x plus 6, well, let's see, 3, 5, 6, and it's going down 1 over 1. So somewhere, again, this wasn't like a super accurate graph, but somewhere up in this area, those points are going to cross. I should say those lines are going to cross at a point somewhere up there. And again, my drawing, my sketch here was pretty rough. We'll find the exact one here in just a second. So if you talk about systems of linear equations, though, normally if you have two lines, they're only going to cross in one location. Now there is a chance, like you graph them both, and they're parallel to each other. In that case, there is no solution. They don't share a point. They don't share a common solution. Or there is a third option. Sometimes you go to graph both lines, and they actually end up being the exact same line. So we have that line, and then you have another one, you graph it, and it's exactly the same line, which means they share all the points. So hopefully that kind of jogs your memory up. Other ways to solve it is you can do substitution or elimination. With elimination, I try to make it so either, let me rewrite it over here, 2x plus y equals 4 and x plus y equals 6. We try to make it so the x's or y's are opposites, so you could times this bottom equation by a negative. So the top one I'm going to leave alone. The bottom one I'm going to times both sides by a negative 1. So I'm going to end up with negative x minus y equals negative 6. And then you add them together. 2x minus x is a negative x. That would be 0. Divide by negative 1, so x equals negative 2. And then to find the y, you plug it back into the equation. And it doesn't matter. You can either plug it into that one or that one. If I plug it in the bottom one, I get negative 2 plus y equals 6. I add the 2 over. So their common solution is when x is negative 2 and y is 8, which, again, my graph wasn't perfect, but it was somewhere up here, right, in the negative 2 positive range. The third way to solve is with substitution. We're going to review that real quick because that's actually the way we're going to solve the systems we're doing today. That's the most common way we're going to do that. So with substitution, I take my two equations, I pick one of the equations, and I solve for either x or y. So for example, I can pick this bottom one and solve for y. So y equals what? Negative x minus 6. And then I take what I got for y and I plug it in for y right there. So 2x plus negative x minus 6 equals 4. So we'd have 2x minus 6 equals 4. That would be x. I could add that 6 over. And I just realized I made a mistake. The equation was x plus y equals 6, not negative 6. Sorry about that. So that should be a plus 6 right there. So I have to, that's a plus 6, sorry about that. So again, I solve for y. I take what y was equal to, I put it in for y right there. 2x plus negative x plus 6. Combine those together, add the 6 over, or minus. In this case, this was supposed to be a plus. So I'm going to change that. Again, sorry about that mistake there. But I'm going to minus the 6 over to the other side. So we get x equals negative 2, which is the same thing as we got before. And then I got to find the y. So again, I take negative 2 and plug it back in for x in one of the equations. I can actually just plug it in right here. It's probably the easiest. Y equals a negative 2 plus 6. That'd be y equals 2 plus 6. 8. And again, when we write a solution, we write it as a pair of coordinate points. So x is -2 and y is 8. Okay, so hopefully that's a good reminder of last year in Math 1 when you solve systems of linear equations. What we're going to do today is we're going to mix it up, and instead of having 2 linear equations, we're going to have one equation that is linear and one equation that's quadratic. So if you look at this example right here, I want to solve this y equals x squared plus x minus 1, and this y equals -2x plus 3. But we're going to solve it. We're going to solve it using substitution. But before we do, I want you to think for a second. This equation is quadratic. We know what that means. That means that the graph is a parabola. This one is linear. So when we solve a system of equations, we're trying to find their common solutions or the points where the two graphs intersect. So what I want you to do is to pause the video for a second. I want you to think about, if you have a parabola and a line, how many possible solutions could you have to that system of equations if you have a quadratic and a linear equation? All right, hopefully you came up with this, right? We could have a parabola and a line that just crosses twice. So you could have 2 solutions to a system of equations. You could have a parabola, it's opening up or down, and a line that never intersects. This would be 2 solutions. This would be no solution. Or it is possible to have a parabola, wasn't a very good parabola, but that has a line that just touches it. We call that actually a tangent line. But if it just touches it once, you've only got one solution. So when we're solving these systems, you got to think about that. How many solutions can we have? You could have 2, 1, or none. All right, let's try this one. We'll solve this system of equations. Honestly, I would always use substitution if you're solving. Oh, let me backtrack for just a second. We could solve this by graphing, just like we did up above. The challenge is it's really difficult to graph a parabola accurately enough to find exactly where a line crosses. So if you're going to solve by graphing, we have to use a calculator. So I'm not going to go through that on this video, but feel free to talk to me about it. I can show you how to do it on the graphing calculators and find where they cross. The drawback to that is you have to have a calculator. So if you don't, you can't solve it that way. So we need other methods. So that's what we're going to focus on in this video and on the assignment, is solving it by substitution mainly. And I'll show you one example of elimination. Okay, so with substitution, again, we want to solve one of the equations for x and y. In this case, they're both solved for y. So that one's solved for y right there. I'm just going to take it and substitute it in for that y right there. And so when I do, I end up with this. -2x plus 3 equals x squared plus x minus 1. Now, the challenge you're going to have with this is that it's a quadratic equation, right? I've got an x squared, and so it's not quite as easy to solve as a linear, but we've been working on this a lot, so we're good. We can solve this equation. I want to get one side equal to 0. I want to put it in standard form. So I'm going to add the 2x over, combine it with that x, and I'm going to minus the 3 over, and I can combine it with that. So over here I get 0 equals x squared plus 3x minus 1 minus 3 minus 4. Okay, now I need to solve that quadratic equation. Well, think of the ways we can solve these. We solved it by graphing, but we need a calculator for that. We solved it by factoring. We could try that. I think that works in this problem. We could do the square root method, but the problem is it's got that x term. That means we can't do the square root method. We could do the completing the square quadratic formula. Honestly, factoring is probably the fastest way to solve it as long as it factors. So let's try it and see. X and x, and I want the factors of -4 that add up to be 3. Well, that's -4 and -1 and +4. So -1 plus 4. We have to set each of those equal to 0. So x equals 1 and x equals -4. Now just be careful. That means it has 2 solutions, but we want to write them as coordinate points. Those are both x's, right? That means it crosses twice. So it crosses once at 1 and once at -4, when x is -4, but I've got to find the y coordinates. We'll just take the 1 and the -4 and plug it back. And you can put it in either equation. It should not matter. You should get the same thing. If not, we've done something wrong. I'm going to use the one that looks simpler, this linear equation. If I plug 1 in, -2 times 1 is -2. -2 plus 3 is 1. So 1, 1 is one of my points where they cross, one of my solutions. I'll plug in -4. Negative 2 times negative 4 is positive 8. 8 plus 3 is 11. Okay, there is the solutions to my system of equations. So that's solving a substitution. Substitution works really well on these, and part of the reason why is usually your quadratic is going to be written in the y equals form. Like it's going to already be written that way. And a lot of times the linear one will be too. And then all you have to do really is, put that in there. Really what you're doing is setting the two equations equal to each other, and then just solving that equation. Let me show you one elimination. I'm not going to spend a lot of time on it. With elimination, the way you do it is, if you remember when we did linear equations, is you want the y's and the x's and the constants to all line up. So I'm going to rewrite it. Let me just switch that. I'm going to rewrite it. But when I do, I want the y's to line up, and I want this one does not have an x squared, so I want the x's to line up and the constants to line up. And then I want to combine them. When you're combining them, I don't want to get rid of the x's because I don't have an x squared that will cancel out with that x squared. So almost always with these systems, if you're going to do elimination, you have to eliminate the y's. Well, right now the y's are not going to cancel out, but if I times both sides by -1, it would flip all the signs. And now the y's would cancel out. So y minus y is 0. I've got an x squared. That would be 0. -2 plus 8 is 6. And that goes away too. So now I just need to solve that equation. Well, again, we have all those different methods. This one does not factor. If you have x squared plus a number, it will not factor. You could try solving. The square root method actually works nice on this because the x term is missing. So let's just get the x squared by itself. So -6 equals x squared. Take the square root of both sides. So x equals plus or minus square root of -6. Now, if you remember, we solved equations like this, and what it means is it's going to have an I in the answer. That means it has complex solutions. When we're solving a system of equations, we're only solving in the real number system. What that means is that if you end up with the square root of a negative, it's actually this case right here, going back up here. It's this one right here where they never cross. And since we're only dealing with the real number system, all we say down here is that this system of equations has no solution. So whenever you go to solve when you do the elimination or substitution, you'll end up with a quadratic. When you go to solve that, if you end up with the square root of a negative, whether it's using the square root method or the quadratic formula or completing the square, you can stop there. Okay, we know that they'd never cross and that there is no solution. Let me just do another example of solving with substitution before we end the video here. Let's take a look. Let me find the one I want. Let's do this number 8 right here. It says elimination. Again, I would suggest just always doing substitution, honestly. Okay, so they're both solved for y, so I'm going to take that and plug it in for that y up there. We get 5x minus 4 equals 9x squared plus 8x minus 6. You want it in standard form, so minus the 5x over and add the 4 over. We want it equal to 0. So we end up with 0 equals 9x squared plus 3x minus 2. Okay, you could try factoring this, but because of the 9 out there, it's going to be harder to factor. I'm just going to use the quadratic formula to solve it. So x is equal to negative b would be -3 plus or minus the discriminant. We'll figure that out in a second, all over 2 times 9. So let's do the inside part. It'd be b squared. That'd be 3 squared minus 4 times 9 times -2. That'd be 9 minus, well, the minus 4 times 9 is a -36, times a -2 is a positive 72. Okay, so we add those together, we get 81. We can keep going. It'd be -3 plus or minus the square root of 81 is 9. So now I've got to go -3 plus 9 over 18 and -3 minus 9 over 18. So that would be what, 6 over 18? This would be -12 over 18. We can reduce both of those. So my x-coordinates, this will be fun. We got some fractions. I got what, 1/3 is one of my x's. I got to find the y. And let's see, 12/18s, you can divide them both by 6, so it'll be negative 2/3. I've still got to find the y coordinates though, so I'm going to take 1/3, and this will be fun. We got some fractions going. I'm going to plug them back in there. So I'm going to go y equals 5 times 1/3 minus 4. That would be 5/3 minus 4. I'm going to write 4 as being 12/3. So 5 minus 12 is negative 7. Let's plug in 2/3. So y equals 5 times 2/3 minus 4. So again, that would be 10/3. And minus 4. I'm going to write 4 as being 12/3 again. So 10/3 minus 12/3. 10 minus 12 is negative 2. Okay. There's a solution to my system of equations. All right, so that's pretty much it. Again, I would recommend doing substitution. That's the first thing I would go to. Elimination you can do, and if you like it, great. Substitution with these problems, honestly, is just faster and easier in most cases. Trying to think if there's anything we missed here. I think that's mainly it. Go through the assignment. Make sure you keep track of your questions and just let me know if you have any. Thanks, guys.